Hello, welcome to office hours. We'll get started in a few minutes, but yeah, so say hi if you're here. I want to see who's here. And then just, yeah, I don't have any, I mean, I have those questions prepared, but I want you guys to tell me which questions we should go over. Hello, Sam, it's nice to see you. Navik, what time is it for you right now, Navik? I thought you were in Europe somewhere. 11 p.m. here in UK. Wow. Well, it's a good way to spend your Wednesday night, I'd say. Sam is trying to prepare for calc in the fall. Nice. Yeah, so you'll see what optimization and integration looks like. Herbert, glad you're here. Dr. Y is in the house. Good to see you, Dr. Y. We're doing optimization and integration tonight. Let me make sure that my camera is correct. Gotta get the top of the board. That's probably as good as we're gonna get. Good enough. All right, yeah, about a minute, we'll get started. Navik says, can't tell what that first thing is. It looks like you got some sort of beer, sip, and a smile. What is that first thing, a moon? All right, well, it's 6 o'clock, so we could get started. So if anybody has some sort of beverage with them, I got my Wake Forest plastic cup filled to the top with water. We could do the simultaneous sip. All right, so let me see in the chat who sipped and what are we sipping tonight? Beer for Navik, water for Molly. Jax went with the spring air. Will went with some H2O. That's what the chemists call water for those wondering. Nicole sipping on the Chick-fil-A sweet tea. Oh, that is some good stuff. All right. Yeah, so keep, can have some fun in the chat today. It's really okay. It's just kind of office hours. Yeah, so what do you guys want to get started with? Are there particular questions from the review that I posted on Canvas that you want to go over? Water. Okay, Dr. Wessel Couch. Yeah, no, it is. It's water. I would get fired so fast. All right, what do you guys want to talk about? Turner says, I just showed up and there are already more people in chat than in class. Yeah, I think people are tired at 10 o'clock for whatever reason. Okay, Will, this was not a review, but practice test 4A. Yeah, and then we could go over 7, Sarah. Okay. Yeah, Sam, I said I opened it up to anybody who wants to come to these office hours if they want to learn some calc. Can we do problems where you turn a function into a limit? And yeah, we'll do that also, Jack. So we'll start with Will's question, then we'll do Sarah, then we'll go Jack's. So just Will's one is quick, right? So Will, your question was a function f that is continuous and differentiable on some interval, but does not obtain an absolute max or min. So correct me if I'm wrong there. Oh wait, no, that's the wrong test. Okay, well, Will, now tell me if I'm wrong. Find an approximation for some integral using a Riemann sum with left endpoints and n equals 3. Do not waste your time simplifying your answer. It was a derivative of a definite integral one. 4a? Oh, 3a. Oh, God, can I look at the right question? All right, one last time. Find the derivative of a definite of an integral. Okay, so here we go. So it's find the derivative of the integral from x to 0 of t over t squared plus t plus 1. All right, so anybody in the crowd, anybody in the chat, how do we go about finding the derivative of this function? So we'll call this g. How do we find g prime? Yeah, we're going to use FTC1. You're right, Nicole. And so in order to use that, we need to have a constant on the bottom, and we need to have our function, or x, basically, on the top. So yeah, let's take g of x, and it's equal to negative the integral from 0 to x, right? If you flip the order, if you flip our bounds, it comes at a cost of a negative sign. Okay, and then FTC1 says the derivative of this integral well, we have the negative from here. You replace all the t's with x's, or you replace all the t's with the function that's on the top bound, which is x here. And then you would multiply by the derivative of that function, which is just 1. So g prime is negative x over x squared plus x plus 1. And that's it. So this question really is just to make sure you knew how to use FTC1. So if you want to look up more on that question, it's the fundamental theorem of calculus part 1 is what we use here. That answer your question, Will? That isn't that bad. Yeah, you're right, Sam. You know FTC1, it's a very powerful theorem. So Sarah then said, can you go over 7? Okay, before we do that, Nicole says, so we multiplied by the derivative of the upper bound. Yeah, so there's really like a 1 here. It's like we're using the chain. You still have to use the chain rule when you take the derivative. It just happens that our top bound is x. If it was something a little bit more complicated, then it'd be, if this was x squared, then you'd have a 2x here. I have a video. I have a video on FTC1 that has a bound that's not x. It's a little bit more complicated, so you can take a look at that. So Sarah said, can we go over number 7? For 7, I got f of. Okay. Yeah, good. All right, so we can work through the whole thing on the study guide. Yeah. So it was f double prime is 24x squared plus 6x plus 4 f of 1 equals 10, and f of negative 1 is equal to 4. All right, so how do we get started on this question? The question is find f. We're not going to do any related rates problems today. Maybe closer to the final. That was on our last test. So how do we find f here? Antiderivative. Yeah, take the antiderivative of f. So I guess I didn't write the question, but it says find f. So f prime, we're going to just use the power rule both times. So it's going to be 8x to the third plus 3x squared plus 4x plus c. And then we take the antiderivative again, or find the antiderivative again, to get f of x is equal to 2x to the fourth plus x to the third plus 2x squared plus cx plus d. Right, and so where do we go from here? This is where you got to, right, Sarah? But anybody, how do we find f? Can you just set up a systems of equations? F of 1 equals 10, f of negative 1 equals 4. Yeah, let's just use our points and see what that ends up giving us. So f of 1, which is 2 plus 1 plus 2 plus c plus d, is equal to 10. F of negative 1, which is 2 minus 1 plus 2 minus c plus d is equal to 4. So this is 2 equations and 2 unknowns. Right? 5 plus c plus d equals 10, which is the same thing as c plus d equals 5. And then the next one is 3 minus c plus d equals 4, which is the same thing as minus c plus d equals 1. So how do we solve the system of equations? Well, maybe just as a reminder, you could add these two equations together. Plug in one. Yeah. What Nicole said and Jared and Navik said, all of those are good ways. Add these together, we get 2d equals 6. And so d equals 3. And then you plug that into either one of these equations, whatever one you think is easier. Maybe the first one, c plus 3 equals 5, so c equals 2. And so the answer is f of x equals 2x to the fourth plus x to the third plus 2x squared plus 2x plus 3. Right, so once you got to the once you took the antiderivative twice, you're just left with a system of equations, 2 equations and 2 unknowns. It's like finding where 2 lines intersect, if you want to think of it in that context. All right, I think Jax had a question, but I can't see it in the chat anymore. So Jax, do you want to repeat what your question was? Can we do a problem where you turn a function into a limit of sums and then evaluate it with the I square and I to the third thing? Oh, does it say f prime of 1? I think it said f of 1. Yeah, so which one would you prefer, I squared or I to the third? I mean, the process is identical. We could let's do number 9 from the review questions, because that uses the I to the third one. Oh, cool. I just said that. So number 9. So we want to find the area under the curve y equals x to the third on the interval 0 to 1. Okay, we want to express it as a limit. And then we want to evaluate the limit using the fact that the sum from I equals 1 to n of I to the third is equal to n squared times n plus 1 squared over 4. So I would give you this information. Okay, even though you have open notes for the test, I would give you this information just to be nice. Okay, so how do we evaluate the area under the curve from 0 to 1 as a limit? And while you're thinking about this, I need somebody. This is very important. I need somebody at 6:45. So that's in 30 minutes. Yeah, we're going to rewrite the limit definition. In 30 minutes, somebody has got to remind me to start preheating my oven. Okay, so that's very important. It's a good way to get on my good side. Okay, it'll take 1 second, but I don't want to forget. All right, so let's write out what the limit definition of the integral was, right? It was the sum, or it was the limit as n goes to infinity of the sum from I equals 1 to n timer set. What are you cooking? I got some. I chopped up some beets and some sweet potatoes. So I'm gonna roast those bad boys up. You know, it's simple. I'm not much of a chef, but keeps me alive. I'm also gonna cook some chicken, but that I'll deal with that after class. Yummy. All right, so yeah, so we got to figure out what is x sub I, what is delta x, and then staying healthy, big dog. All right, how do we get x sub I? Calc teacher by day, chef by night. What can I say? All right, x sub I. I guess we should start by, right, x sub I we said was a plus I delta x. So I guess we should start by finding delta x. So how do we remember how to find delta x in this in these examples? Yeah, so it's always just going to be the length of our interval, which is b minus a, so 1 in this case, over n. And so x sub I, which we said was a plus I delta x, a is 0 and delta x is 1 over n, so this is I over n. Okay, so what we want to do is the limit as n goes to infinity of the sum from I equals 1 to n. I guess even before we do that, we should write out what f. So f of x sub I is I over n to the third, which we could write as I to the third over n to the third. And so we want to evaluate the limit as n goes to infinity of the sum from I equals 1 to n of I, I'll write this a little bit bigger, of I to the third over n to the third times 1 over n. All right, so that's what we're trying to evaluate, the area under the curve. But the second part of the question said actually evaluate it. Right? N to the third and n, it's n to the fourth. Right, are we happy with this so far? Pulled out a 1 over n to the fourth, and we're left with the sum from I equals 1 to n of I to the third. What do we do now? Are you are we good now with the stream, or are there still problems? Plug in the identity. All right, let me know if the stream is working. Maybe refresh on your side. I'm not going to refresh on my side because that's going to end the whole stream. Okay, so let me recap what we did. I was lagging. Let me see what. Yeah, I'm on my strong Wi-Fi, so this is the best we're going to get. Better now. Okay, well, this is the best we could do. So hopefully this works out. All right, let me just kind of recap. I see if you see what see where this is going. We found delta x, we found x of I, we found f of x of I. We plugged it into our limit definition of the integral, which is this. We can factor out the constant, and then yeah, we have the identity. So let's use the identity. Right? So you got to get into this form first before you use the identity. Okay. So how do we evaluate this limit? So we want to evaluate the limit of this rational function in n. Yeah, so yeah, we're going to take the limit at infinity. I said we could use shortcuts with these rational functions. So you could look, the degree of the numerator is 4, right? N squared times n squared. The degree of the denominator is also 4. So this limit is just the quotient of their leading coefficients, which is 1/4. Okay, and so the question for you, and that's the answer. But my question is, how do we check our answer? What's an easy way to check that we did this correctly? Right, so we wanted to find the area under the curve of y equals x to the third from 0 to 1. We found it was 1/4. Yeah, let's just take the integral. So the integral from 0 to 1 of x to the third dx is equal to x to the fourth over 4 evaluated at 0 and 1, which is 1/4. Okay, so that's how you check your answer. So there's no excuse to get wrong answers on these because we have a really easy way to check our answer. All right. What else should we do? Is the stream working still? I guess if it's not working, you won't be able to hear what I'm even asking. But are there any other types of questions you want to go over? Stream works, kind of. Yeah, I wonder if it's easier to stream in the morning because fewer people are using the internet. I don't really know how it works. Can we go over 13? Yes. I'm totally clueless. I'm Dr. Wesselcouch. Classic. All right, number 13. Who asked for that? Rena? Yep. So this is number 13. So which is largest? All right, which is largest? The integral from 1 to 2 of x dx? The integral from 1 to 2 of 1 over x dx? Or the integral from 1 to 2 of the square root of x dx? Does anybody have any ideas of how we could answer this question. All right. Well, now Navik guesses third, but I need what's some reasoning. I'm not sure if I'm even. I don't think I even like that answer. But let's get some reasoning instead of guessing. I guess I asked for a guess, but can somebody try to give me some logic for how they would go about solving this? Graph the functions and intuitively see which one it is. That will give us a way to have a conjecture for which one is the biggest, but we want to say it with 100% certainty. Could you integrate them and see which ones are the largest? I mean, we could, but we know how to integrate this. We know how to integrate this. We don't know how to integrate this, okay? And if you see a function on the test that we don't know how to integrate, and you somehow learn how to integrate it, that would be very suspicious. Right? So we're going to need a different method than that. Well, let me ask you this. So on this interval 1 to 2, symmetry, yeah, that's a good idea, but not quite. The symmetry theorems only worked when we had like an interval that went from like negative a to a. These don't. What Hamzali said is actually kind of on the right track. Yeah, x is always larger than 1 over x and the square root of x. So would it be number 1? Yes, that's the trick on this one. We know that x is greater than or equal to 1 over x on this interval. And we know that x is greater than or equal to the square root of x on 1 to 2. So this integral is larger than this integral. And similarly, this integral is larger than that integral. So integral 1 is the largest. We haven't gotten to the chapter on how to integrate 1 over x. It uses, I don't know if I want to spoil it for all of you. It deals with the natural log function. Yeah, so we would use this fact. Since x is larger than 1 over x on our interval, and x is also larger than square root of x, we could conclude that this is the largest. Don't spoil it. The second one isn't log 20, is it? Close. Not 20, but maybe log 2. Yeah, but the key on this one is, we had these results about, I mean, I know we didn't talk about it too much, but we had a theorem that said, like, if one function is always larger than the other function, then its integral is also going to be larger. And so that's what we used here. Okay, so because the question's not asking for which one's the biggest. I mean, what is the exact value of the biggest? It's just asking which one is the biggest. We don't care about the numbers. So what else should we work on? No, it's not the inverse. The highest function will have the largest interval. Integral. Can we do 17 and then 15? Yep. We'll just do them 17 and then 15. Sorry, Jared, but you're too slow. All right. I'll actually, since they're both integrals, we'll just do them both at the same time. So you're lucky, Jared. All right. So 17 and 15. Start with 17. Okay, so 17 wants us to integrate this product. And 15 wants us to evaluate this quotient, the integral of this quotient. Squared minus 2x plus 3x, that's plus x, minus 2. Okay, I see some people said the stream is down. Hopefully it's back. Is it back? Well, again, refresh if it's not working. This is the best we could. This is the best we got. The chat's at least working. Okay, well, some people say it's back. Yeah, so then we just integrate. So what we did, Molly says it's working. Maybe reduce the resolution. We need Wake Forest IT services. Huh? That's true. Yeah, I don't think I could change the resolution midstream. Yeah, I think maybe you guys can. If you hit. Yeah, but the audio is. If it's the audio, the resolution's not going to help at all, probably. Okay, so we just integrate each of these components, right? X to the third plus x squared over 2 minus 2x, evaluated at -1 and 2. Which I have in my notes. So you should check this, but I believe it simplifies to 9/2. I could buy that. Okay. Does the line with the upper and lower bound just replace the C when we do? Yeah, so this is just saying, this is just a way to remind us we have to evaluate at 2. Yeah, let me write out the in-between step. So we would plug in 2 into this function, which would be 8 plus 2 plus 2. And then, so this is the function evaluated at 2. This is the function evaluated at -1. And if we did this correctly, you should get 9/2. 6 minus 1.5 is 4.5. I like our answer. All right, so how do we do 15? How do we evaluate the integral from 1 to 4 of 2 plus x squared over the square root of x? All right, well, the stream might be frozen again. And if it is, I'll get started on the question and hopefully it kicks back in. Substitution. What would we try for substitution? Maybe quotient rule. We don't have a quotient rule for integrals. We have one for derivatives. Let's see if this helps. Okay, so it's the integral from 1 to 4 of 2 plus x squared over the square root of x. It only applies when our interval goes from negative a to a. So this is 1 to 4, so that doesn't apply. Yeah, so let's break apart this integral. And this is now, we could rewrite as the integral from 1 to 4 of 2x to the negative 1/2. X squared over x to the 1/2 is x to the 3/2. There's no stutter while watching this on my Nintendo Wii. No joke, that is the video game system I still use. So, yeah, play Guitar Hero sometimes. All right, and then these are easy to integrate, right? So the integral of x to the negative 1/2, increase the power by 1 and divide by the new power. So we get 4 x to the 1/2 plus 2/5 x to the 5/2, evaluating at our endpoints. Four to the 5/2 is the same thing as the square root of 4, which is 2 to the 5th, which is 32. And I don't have this simplified, but whatever this simplifies to, I guess we could try to simplify it a little bit. 8 plus 64/5 minus 4 minus 2/5. Yeah, so 4 plus 62/5. Timer, oven, thank you. All right, I'll be right back. In the chat, let me know what questions we should work on. All right. Oven is preheating. Hopefully it finishes heating, preheating, right at 7 o'clock. 18. I was typing oven, LOL. Will we need to simplify all the way for the exam? No. 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 Just no. Don't worry about the algebra. Like going from here to here to here makes it very clear to me that you know what you're doing. I don't care too much how well you could simplify. So leaving it like this is perfectly fine. 18, you say. And then 8. All right, where are we? Here, 18. All right, so sketch the region enclosed by the curves y equals 2x minus x squared and y equals 0. And then we want to find its area. All right, and we just need a rough sketch, just good enough so we can figure out how to find the area. Right? I don't need you to go through all 7 facts needed to graph a function by hand. But we should have a general sense. So we know that this curve looks something like this, right? It's a parabola with a negative leading coefficient. And this is just the the x-axis. So the question is, where do they intersect? How do we find this x value? How do we find that x value? Yeah, so basically the way you find how where two functions intersect is you set them equal to each other. So we would set 2x minus x squared equal to 0 and solve. Well, we could factor out a negative x. And we get that x equals 0 and 2. Okay, so now how do we find the area of this region? How do we find this area? Take the definite integral, and the bounds are 0 and 2. So a equals the integral from 0 to 2 of minus x squared plus 2x dx, which is negative x to the third over 3 plus x squared evaluated at 0 and 2. Which is negative 8 thirds plus 4 minus, when you plug in 0, you get 0, and that's 4 thirds. All right, so Josefa asked for 8, so let's do 8, and then that could be a good place to stop. So we'll still have some questions to work on tomorrow. But do yourself a favor I mean, you're also doing me a favor, but do yourself a favor and look at these questions tonight. Look at all the questions that I posted on Canvas tonight. You don't have to do them. Just look at them and figure out which ones are hard and which ones, so we could go over some hard ones tomorrow. Okay? Because we'll have another 50 minutes or so to be working on these tomorrow. But let's do number 8. Okay, find an expression for the area under the graph of f of x equals 2x over x squared plus 1. And we go from 1 to 3. So we want to find an expression for the area under this graph as a limit. Do not evaluate the limit. So how do we do this? So we want to find the area from 1 to 3, expressing it as a limit. So what's our method for doing that? Yes, Jared. You're exactly right. We should start by finding delta x, then we'll find x of I, f of x of I, put it all together with our limit definition, and then we're done. It says don't evaluate the limit, so we'd be done at that point. Right? This limit, you could imagine, will be pretty complicated to evaluate. So delta x, we should be sick of going over these by now. B minus a over n. You know, you're an expert at this point. So 2 over n. X of I said is a plus I delta x. And f of x of I is 2 times 1 plus 2i over n over 1 plus 2i over n squared plus 1. Right, and now that's all the information we need. So we put it all together. So the area under the curve of f of x equals 2x over x squared plus 1 from 1 to 3 is the limit as n goes to infinity of the sum from I equals 1 to n of f of x of I times delta x, which is 2 over n. Right, and you know, just looking at it, you could see that this is an absolute disaster of a limit you'd be trying to evaluate. So that's where integrals and our integration techniques come in handy. We won't have to evaluate these limits. We would instead treat this as an integral. Not that we know how to evaluate this integral yet, but someday you'll learn. All right. Well, I think that's a good place to stop for today. As my friend Navik always says during class, make sure to smash the like button before you get out of here. Helps the channel. And it helps you. It's good luck. But yeah, so I think that was fun. We'll do it again tomorrow morning. I'll stay around if anybody has any last minute questions that could be answered, you know, just kind of quickly. But yeah, we had what? At one point, I think we had 20-something people here. It's pretty good. You're welcome, Jared. Thanks for coming. Smash the like button like the Incredible Hulk. Turner says, I have a question. Yes. If I get an A on the exam, will you one-on-one me in Mario Kart Wii? Ooh, that'd be fun. Who do you play as? I kind of, wasn't there one character in Mario Kart Wii that's like overpowered? Funky Kong or something? I don't know. It's been a long time. Toad, sweet. Yeah, Waluigi I would play as sometimes. Daisy occasionally. All right, any other questions? I'm not that good, trust me. Turner, I'm telling you, when I was in college, I spent probably, I don't know, 200 hours playing that game my freshman year. Does that make sense? It was like every single day we would play that game. But I haven't played since. Okay, enough of this. Bye-bye.